Good morning, girls. Today we're going to start a new lesson in chapter 2, which is lesson 3, that talks about families of functions. Okay, now there are a set of functions called families in which each function is a transformation of a special function called the parent. Okay, so we have something called the parent function. The parent function here. The parent function is y equals x. This is the parent function. Okay, we have different families of this parent function. It means we have different transformations of these functions. The first transformation we're going to have in this lesson is the translation. One type of transformation is a translation. A translation shifts the graph of the parent function horizontally and vertically, or both. I mean horizontally or vertically or both, without changing shape of the orientation. It means, for example, if we're having y equals x, its orientation is obviously this. Okay, it's not purely accurate. This is y equals x. Now, the translation, it means it's going to move this horizontally, it means to the right or to the left, but it's going to have the same shape, or it's going to move it upward or downward vertically, but it's going to have the same orientation or the same shape. Okay? Now, for a positive constant k, a parent function fx plus or minus k is a vertical translation. For a positive constant h, fx plus or minus h is a horizontal translation. Okay, so let's put in mind, like k is the vertical translation and h is the horizontal translation. But how can we differentiate between them? For example, if I gave you y plus 3, fx equals fx plus 3. You're going to move it here upward or downward, like you're going to move it vertically or horizontally here. You're going to move it vertically, either upward or downward. Now, how to differentiate between the vertical and the horizontal? This is vertical. The horizontal is going to have, for example, y plus 3 inside the bracket. So when you have the transformation here inside the bracket, it means that the translation is going to be horizontally, either left or right. This is the difference between how to differentiate, like between how to move it vertically or horizontally. Now here, let's see the vertical translation. This is the original one, okay? Adding k to the output shifts the graph upward. So here, this is fx. If I added plus k, it's going to move upward. If I subtracted k, it's going to move downward. Now again, here for the horizontal translation, here's the original one, okay, or here's the parent function, which is fx. Now, if we're adding h, it means it's going to move left. Why? Because like when we say y plus 3, you're gonna like y plus 3 equals 0. So if you're gonna move y to the 3 to the other side, it's gonna be minus 3. So it means you're going to move to the left. So just put in your minds, when it's positive here, it means you're going to move to the left. When it's negative, it's going to move to the right. Okay? So now let's start solving the first problem we have. Now problem 1, it talks about vertical translation. Okay, so here part A. How are the functions y equals x, the parent function, and y equals x minus 2 related? How are their graphs related? Okay, so now we're going to see here that we're going to make a table for x and y equals x. So when x equals negative 2, y equals negative 2. Negative 1, 0, 0, 1, 1, negative 2, 2. Now here for this part, okay, which is the second fraction we have, which is y equals x minus 2. It means negative 2, you're just going to substitute x over here. So negative 2 gives me 4. Here, negative 1, negative 2 gives me 3, and so on. So you're just going to substitute and find it here. Now, this is when we make the tables, when we make the values, solve the values in a table. This is the difference. And for drawing there in the graph, this is the original function here we have. This is the original graph, which is y equals x. Now, we said y equals negative x. Is this inside a bracket or not? It's not inside a bracket, so it means you're going to move vertically, right? Now, because it's negative, it means you're going to move vertically downward or upward. It means you're going to move, because it's negative, it means it's going to move downwards. Okay? Now, let's see here. There are comments here for the table and for the graph here. Each output for y equals x minus 2 is less it is 2 less than the corresponding output for x. So it means here -2, we have -4, it's 2 units or 2 digits or 2 values lower than or less than -2. -3, it's 2 values less than -1. -2 is less than 2 values from 0, and so on for the rest of the table here. Okay, so that's for the table. Let's see here for the graph. The graph of y equals x minus 2 is the graph of y equals x translated down to units. So it was here, then it translated down 2 units, this point. For example, this point it translated 2 units. For example, this point 2 units, and so on, all other points. So it means y equals x translated down into units. Okay, let's see the second example we have here. Okay, what is the graph of y equals x squared -1 translated up 5 units? Okay, let's now graph it together. Okay, so here, let's solve it together. What's the graph of y equals x squared minus 1 translated up 5 units? Now, when we say translated up 5 units, it means let's say y equals x squared minus 1. Translated up 5 units, it means plus 5, right? So we're going to add here plus 5. So it's going to be as y equals x squared minus 1 plus 5, which is plus 4. Now we want to graph this. But first of all, we're going to have, for example, values of x. And then, let's say this is equation number 1. And this is equation number 2 because we don't have so much space to write it here. So let's say this is equation number 1, the answers for equation number 1 and the answers for equation number 2. Okay? So let's have, for example, values for x. Let's have, for example, -2, -1, 0, 1, 2, 3. Okay? So -1, if we want to substitute -1 into this equation, it's going to be -2. -2 squared, which is 4, minus 1, which is 3. -1 here, it's going to be -1 squared, which is 1 minus 1, which is 0. 0, it would give me 1. 1, it would give me, again, 0. 2 squared, 4 minus 1, which is 3. 3 squared, 9, minus 1, which is 8. Okay? So this is the answers for this equation. Now let's see the total equation that we have here, equation number 2, which is y equals x squared plus 4. We're going to substitute the answers here. -2 squared plus 4, which is, it's 4 plus 4, which is 8. -1 squared, which is 1, plus 4, which is 5. 0 would give me 4. 1 would give me 5. Again, 2 would give me 8. 3 squared, 9, plus 4, 10, 11, 12, 13, so it's going to be 13. I already know this. I won't graph this because it will give me a big number. So now, let's graph it. Okay, now so let's graph. Let's remember that this is y squared equals y equals x squared minus 1, and this is y equals x squared plus 4. So it means that the values here are the answers for the values of y and for x values, and here are the answers of y of this equation for x values. Okay, so now let's graph them. When we have x equals -2, y equals 3, so it's somehow over here. -1, 0, -1, 0, so it's going to be here. 0, -1, 0, -1, so it's going to be over here. 1, 0, 1, 0, again, it's going to be over here. And 2 will give me 3, 2 will give me 3. So let me now put them all together. It's going to be, oh wait. it's gonna be this way. It's a parabola, okay, because it's x squared, so obviously it's gonna be a parabola. Let me just try drawing it again properly here. It's somehow a parabola, okay. So now this is x squared equals -1. Let's see here how many units did it translate, okay. So let's have another color here. Okay, now -2, 8, -2, 8, and then -1, 5, -1, 5, and then 0, -1, 0. I mean, sorry, 0, 4. It's gonna be over here. Then 1, 5 again, 1, 5. Then 2, 8, 2, 8. Okay, so let me now draw it over here. So it is a parabola because it's x squared. So it does not. What is it called? Yes, the orientation does not change. Okay, only it translates. So here it translated vertically upward from -1 up to 5. So how many times? How many units? 1, 2, 3, 4, and 5. So it's like from -1 up to 4, we have 5 units upward, as it was asking. Okay, so now let's check the question, the answer together. Okay, yes, so they got the same numbers here. Translate the graph 5 units upward. So we made this equation because it's going to be -1 plus 5, which is x squared plus 4. So we made the answers for this to graph the original one we have here, which is y equals x squared minus 1. Then we graphed x squared plus 5. This is after 5 units, after moving the graph 5 units upward. So that's right. Now let's go for the second question we have, which is part B. Which is a question from the book. How are the functions y equals 2x and y equals 2x minus 3 related, and how are their graphs related? Okay, so let's solve this together. Okay, so to find how are they related, we're going to have some values here, like x values. So we can find y equals 2x, y equals 2x, and y equals 2x minus 3. So girls, here in this question, from without like graphic or anything, when you see the function y equals 2x minus 3 and y equals 2x, you say what did it happen here for y equals 2x? Obviously here, because there's no brackets, the movement or the translation is going to be vertical. -3, it means it's going to be moving downward 3 units. Okay, so now let's have some values here to find 2x and 2x minus 3. Then we're going to graph it together. Let's have again the same numbers we do: -2, -1, 0, 1, 2. Let's have here -2 times 2, -2 times 2, which is -4, -1 times 2, which is -2, 0 would give me 0, 1 would give me 2, 2 would give me 4. Okay, so now let's have the answers for y equals 2x minus 3. -2 times 2, which is -4, -4, -3, which is going to be -7. -1 is going to be -2, -3, which is -5. 0 is going to be -3 here. 1, 2 times 1, which is 2, 2 minus 3, which is 1, -1 here. 2 times 2, 4, 4 minus 3, which is 1. No, wait, just a second here. Oh yes, that's right. Okay, so now we have to graph all these numbers so we can find the answer. Okay, so let's graph it together. Okay, so let's now graph the first equation here, which is y equals 2. Now when -2, it would give me -4, which is over here. Oh, -4, which is over here somehow. -1 would give me -2, -1 would give me -2, 0 would give me 0, 1 would give me 2, 2 would give me 4. Okay, so just let me somehow have, it's going to be a straight line that passes through all of them here. This is going to be somehow the graph for y equals 2x. Now let's see y equals 2x minus 3. So minus 3 is going to be like moving 3 units downward. Okay, so now let's have another color here to graph y equals 2x minus 3, which is negative 2, negative 7, negative 2, negative 7. It's going to be over here. Then negative 1, negative 5, which is over here somehow. Then 0, negative 3, then 1, negative 1, which is over here somehow, and then 2, 1, 2, 1, it's over here. Let's make a line between for them. Somehow it's going to be, okay, so this is going to be the graph for y equals 2x minus 3. It translated 3 units downward. So when we say how are they related, it means you have to say it translated. Okay, I'm just gonna write it here. It's gonna be as translated 3 units downward. Okay, this would be the answer for this question. Let's see the solution for this question, if it's the same or not. Yes, here each output for y equals 2x minus 3 is less than the corresponding output for is 3 less than the corresponding output for y equals 2x. And for the graph part, the graph y equals 2x minus 3 is the graph of 2x translated down 3 units, as we said. Okay, so that's how the translation or the vertical translation works. Let's now see the horizontal translation. Some questions for the horizontal translation. Okay, the graph shows the projected altitude f of x of an airplane scheduled to depart an airport at noon. If the plane leaves 2 hours late, what function represents this transformation? Okay, so here it's going to be like a word problem. From it, you're going to find the answer here. So a 2-hour delay means the plane leaves at 2 p.m. So this is the 2 hours delay. Okay, so let's now think together. It's going to be as fx, right? Equals, for example, f of x, equals, for example, when it leaves at 3. Let's see, the altitude is going to be 5, for example. Okay? Now let's think about when f equals, or when the plane leaves 2 hours late, it means like fx minus 2 hours. So it's 2 hours late. So it's going to be as 5 minus 2. This is as an example here. So here, for example, let's say it's supposed to leave at 0 hours after noon, like at 12 o'clock, okay? Now, if it was 2 hours late, it means it's going to leave at 2 o'clock. Or 2 whatever. If here it's AM or PM, it's going to be the same as AM or PM, okay? So like from 12, 2 hours late is going to be like 2. So negative 2, it means it's going to move to the right. Okay, so this is how this function represents this transformation. Because it moves to the left, it means it's going to be negative 2. Now let's see the second example for our horizontal translation here. The graph shows the projected altitude again of an airplane scheduled to depart an airport at noon. Suppose the flight leaves 30 minutes early. What function represents the transformation? So again here, it's going to move as 30 minutes earlier. It means 0.5 hours early. Girls, why are we why is this moving horizontally? Because you see the x-axis here is the hours afternoon. So they're talking about the hours here. It means it's gonna move horizontally because the hours here, it's the x-axis. So it's gonna be 0.5 hours early. Now, based on this graph here, do we have, if we're gonna say early, it's gonna be before the 0, right? So it's going to move to the left. When it moves to the left, it means we're going to add h, or to add 0.5 hours. This is 0.5. Okay, so fx plus 0.5 represents the transformation because the graph is shifted 0.5 units to the left. In the previous example here, where is it? Okay, in the previous example here, it was shifted 2 units to the right, so that's why we had x minus 2, and here 2 units to the left, so it's going to be plus. Okay, girls, so now you can differentiate if it's adding or subtracting. So again, left you're going to add, and right you're going to subtract. It's the opposite of what we always know. Okay, so just put this in your mind. Now we're done with the translation. We said translation, it means vertical or horizontal. Now we have another transformation other than the first transformation we had was the translation. The second transformation we're going to have is the reflection. A reflection flips the graph of a function across a line, such as on the x or the y axis. Each point on the graph of the reflected function is the same distance from the line of the reflection as its corresponding point on the graph or the original function. Okay, so for example, we have this as the original function. Reflection means as the mirror, when you're having the, it's like looking at the mirror, or the x-axis is going to be the mirror here, or the y-axis. So it reflects about the x-axis is going to be downward here, or when it reflects about the x-axis, the y-axis here, so it's moving to be reflected about the x-axis, which is on its left. When you reflect a graph in the y-axis, the x values change signs and the y values stay the same. Okay, so here's the first point we are having. When you're reflecting the graph about x-axis, about the y-axis, the x values only change. The y values stay the same. So for example here, when you're reflecting about the y-axis, we're having this, right? Because it's moving, reflecting about the y-axis. So here, the y values stay the same as 1 and 4 and 1. Only the x-axis is going to change. Here it's because here it's the positive positive numbers here of the x-axis, or x values I mean. When you're going to move it or reflect it about the y-axis, the x values change the signs. Now, when you reflect a graph about the x-axis, when you reflect about the x-axis, the y values change, but the x-axis, they're the same. So the x value stays the same, and the y values change signs. Okay, so here, when you, again, put in mind, reflecting about y-axis, x will be the opposite sign. When you reflect about the x-axis, y will be the opposite sign. Y will stay as it is, and x will change its sign when you reflect about the y-axis. And when you reflect about the x-axis, y is going to change the sign, and x is going to have the same sign. For a function f of x, the reflection in the y-axis is f, between the brackets, f of negative x, and the reflection of the x-axis is going to be negative f of x. So again, when you reflect about the y-axis, it means the x is going to change. The x itself is going to change, so the x is going to be negative. Here, when you reflect the x-axis, it means the y is going to change. So all of this is y, right? F of x is y, so it's going to be negative y, or negative f of x. Okay, so now let's start solving the problems here we have. Okay, let gx be the reflection of f of x in the y-axis. What is a function rule for g of x? Okay, let's solve this together. Okay, so now let g of x be the reflection of f of x in the y-axis. So it means it's going to rotate or reflect, to reflect around the y-axis. When it reflects around the y-axis, what does change? Values. X change values. It means it's going to be like g of x, let's say g of x is going to be equal to f, because we changed the values of x exactly, so we're going to change f of negative x. Okay, now from this we're going to change this whole equation. So it's going to be as, we're going now to change the whole function. So g of x, now we're going to substitute x here as negative x. So it's going to be as 3 negative x. Oh, what's wrong here? It's going to be negative x plus 3. So g of x is going to be equal to 3 times negative x, negative 3x plus 3. So this will be our new function. And now we have to graph it, okay? So we're going to have some values here. We're going to have values for x and the answer for g of x. So let's have negative 1, 0, 1, 2, 3. Okay? So now let's or let's have like from negative 1 it's going to be like negative 1, negative 2, negative 1, 0, 1, 2. Okay, so now let's graph here. If we substituted negative 2, it's going to be negative 3 times negative 2, which is 6, plus 3, which is 9. Then negative 1 times 3, it's going to be 3. 3 plus 3 is 6. 0 would give me 3. 1 would give me negative 3 plus 3, which is 0. And then negative 3 times 2, which is negative 6, plus 3, which is negative 3. Okay, so let's graph this together. Okay, so let's now graph this here. Negative 2, 9, negative 2, 9, negative 1, 6, negative 1, 6, 0, 3, 0, 3, 1, 0, 2, negative 3, 2, negative 3. Okay, so this is the reflection. Now, how can we know what's the original one here? We're going to also, okay, this is supposed to be like intersecting with all of them. Okay, so this is the reflection of the original one. Now to find the original one here, you're going to also plug in some values for x so you can find what is f of x. Let's see it together now. As for here, we graphed this one, which is the reflection. But originally, this is the original one, which is f of x. Now you can see that this is the reflection here. This is the point of reflecting. Check by graphing f of x and g of x and showing the translation points. So the translation points here that we have, it's from 2, or let's say that here's the original one. We said that when it reflects about y-axis, the y values stay the same, which is here negative 3, negative 3, but the x values have the opposite. So obviously here it's 1 and here it's going to be negative 1. Here it's 2 and here it's going to be the negative 2. So that's for the reflection, girls. Let's have a quick summary here. The vertical translation, it's when you're having to move upward or downward. Here positive k or negative k outside the bracket. Horizontal translation, negative h or positive h inside the bracket. Okay, and here this we're going to talk about it tomorrow. Reflection here in the x-axis, y equals negative f of x. Reflection, reflection in the y-axis is going to be the x itself, so negative x. So I know this lesson is somehow long for you, but it's going to be so easy. So please have your time solving the classwork and submit it when you're done. And have a nice day.